A farmer with 2,000 meters of fencing wants to enclose a rectangular plot that borders on a straight highway, and we're not going to fence the side along the highway. And we want to know the largest area that can be enclosed. Okay, so let's think about a visual here. Here's the highway. We don't need to fence this side. Now, we don't know why. Maybe the government has already put up some kind of a fence or whatever, but we have 2,000 meters then to just fence off the remaining 3 sides. Okay, and you can use variables x, y, whatever. With the way I have this drawn, I would think of this as the width and this is the length. They're just variable names. You can call them whatever you want to call them. Okay, now I have 2,000 meters of fencing to use. That's giving me the measurement of these 3 sides. So 2,000 has to equal, there's 2 of what I've called W and only 1 L. Okay, so here's an equation relating the different lengths of sides for my rectangular plot. What I want is the largest area. So that means I need to maximize. If I want to maximize area, I need a formula for area, which I know to be length times width. I need this formula to only have 2 variables. We usually have a y and an x. Here we're going to have an a, and then either an L or a W. It doesn't matter, it's our call. So where do I get rid of this 3rd variable? That's where this equation comes in. So if I take this equation and rearrange to solve, it's much easier to solve for L than W, because if I solve for W, I'm going to have to divide by 2. But if I take this equation and I rearrange it, I get L equals 2,000 minus 2W. And now I can simply do a substitute in for L. So I now have the formula A equal the quantity, because all of it has to get multiplied, 2,000 minus 2W times W, or A equal 2,000W minus 2W squared. This is a quadratic equation. There's a negative in front of the variable squared, so the graph is going to open down for our parabola. The largest is going to come from the vertex. I can either do this by graphing or by hand. If I do it by hand, usually we say the x value of the vertex, but that would be the independent variable, which is W in our case. Negative b. The b is the number in front of the variable to the 1st power, so 2,000 divided by 2 times a. A is the number in front of the variable squared, so negative 2. That simplifies to be negative 2,000 over a negative 4, so certainly the negatives are going to cancel out. And I'm going to put that in the calculator just to make sure I don't make an arithmetic error. This comes out to be 500. But we got to worry about what does that mean. 500 is W, which is our width. I'm asked to find the largest area. So I've found one dimension. I'm in meters, so this is 500 meters. How do I get the area? Well, I got a few things I can do here. I already have a formula for area in terms of W, so I could just plug that in. So 2,000 times 500 minus 2 times 500 squared. I think this is going to be a pretty big number. Make sure you only square the 500, don't square the 2. This comes out to be, looks like 500,000, and this would be in square meters. Okay, so there's one way to find the area. Another option, once I had the width, I could go back in and find my length. Of course, you only have to do it once, you don't have to do it twice. If I know the length is 2,000 minus 2 times my W, which I just found to be 500, that's 2,000 minus 1,000 or 1,000. And then I could use area is length times width, which would be 1,000 for the length, 500 for the width, and I still get the same answer of 500,000, and I'm in meters squared. So a couple of different options. I found the W algebraically, and then from there I could either use my formula for area or find my length and then substitute in to length times width to find area. Either one is fine.